Okay, gang, a few more view types that I'd like to talk about for our composition project. One is called a section perspective. And I'm going to start with my standard interior perspective here of this space. But what I'd like to do is crop away, cut away the building as if it was a section, but leave the perspective part. And the way you do that is you turn on the section box here in this view. But like we've done in the bird's eye view, I want to cut away the building by displaying the section box from my section perspective in the axonometric view. So I'll just right-click on section perspective, choose Show Section Box. But now here I am in axonometric view. I can drag the section box forward or backward, and if we drag it enough, you'll start to see the section of the building displayed. And this is a really interesting kind of view. Let me just close this out. Because it shows kind of the relationship of the interior to the architecture of the building. And you can modify your crop region here to show more or less of what you like. And of course, the way that the poché renders is the similar problem we see in all of our other views. So I've shown it blue here because it shows up very nicely in a video. So anyway, that's a section perspective. Another type of view that I'd like you to do is what's called a displacement set. And again, I've copied a view of the standard axonometric view of our project. And what you can do is, it's kind of fun actually. I don't know why it's fun. I don't know who finds these things fun, but I do. Which is basically you can select elements and kind of move them out of the way. And these changes only take place in this view. They're view specific. So select the objects you want to move out of the way and click Displace Elements. It's a button up here. If you're running Revit 2014 or earlier, that won't show up. Anyway, there's a little gizmo that shows up. This little icon here is what's called a gizmo. If you click on the gizmo, that allows you to move entire elements up out of the way. So I could easily take, for example, the walls and slide them out of the way. Take this wall and slide it out of the way. And, oh, I left the ceiling in there. Let me edit this group here. I'll choose Edit, and I can add in things that I forgot, and you can see that they snap right up. Here, I'll even put the lighting up there too while I'm at it. And this poor guy needs to be back up on the roof. Anyway, and then what's kind of neat about the whole thing is you can render this view just like any other view. And you can add in features. For example, sometimes it's nice to have these little path lines in there, and those kind of show where the elements that you've displaced come from. It doesn't always work. Sometimes it doesn't like connecting to different objects. But anyway, what's neat is if you rotate the view, those path lines remain. Anyway, and of course in these views you want to make sure you check your crop region to make sure you've got enough space. In this case I've displayed it, and let me check here, 35 inches. That's not too bad for this size of an image. Axonometric views are scaled views, so if you find that your view, the render size is very, very small, it's probably because of the scale, so check the scale. Anyway, so let's go back to the lecture here. Here's a rendered view, and I have put this lecture, this PowerPoint, on Canvas in addition to the discussion. So when you go to render this, all of these images, they don't want to have color. Color, I find, is distracting when you talk about composition. So for each one, as you test render it, you'll want to adjust the exposure so that there is basically zero saturation. Saturation is kind of what the color is all about. And don't forget, when you re-render, you'll always want to use the maximum size that you can get, so image maximum size. And I generally use this alpha transparency background for compositions like this, because then I don't have to crop around objects, or I don't have this annoying white or gray space behind. Sometimes Revit will render in a horizon line, which I don't particularly like. And of course, you want the final quality rendering. And we don't care how long it takes, because we have all the time in the world. The other thing is, you don't have to render each one individually if you don't want. There's quite a few different views in this project. You can just choose Render All Views, and the little Revit gnomes off in the cloud will render them all for you. Of course, it will take quite a while, so obviously don't do that an hour before the project is due. The other nice thing is that if you have a whole bunch of renderings, I have, let's see, 15 here, I guess, you can download them all at once. Okay, and I've saved mine as PNG files just to get the maximum quality, especially in this case where we don't really care. And I tossed them all onto a board here so you can see. Like I mentioned, I actually don't like the way the poche is rendering, and in fact, I think if I do this again, I will try to make the poche render as black. You can do that by controlling the material inside the wall. So anyway, there's one last piece to this composition assignment, which is one really big rendering, 36 inches in its maximum dimension. Now, I want you to choose the composition which you think best represents what you were trying to do in the project. So in this case, I chose the extra wide 4:1 ratio panorama view. And to get that image size to printed at 35 inches wide, you need to think about how many pixels you need. 4,000 pixels isn't enough. How do I know that? Well, I know that because our printer prints at about 200 pixels per inch. That's not the same as dots per inch, by the way, which is how some home printers are measured. What we need is 35 inches worth of pixels at 200 pixels per inch. So to figure that out, you get 35 times 200 is 7,000. And that's a lot of pixels. It's more than the render cloud will allow us, and that's part of the challenge here in this assignment. And there's a couple ways you can achieve this super large size. One is you can actually just change the crop region size to some extra large size. And then you have to render it either on your computer or on a desktop. Now, of course, at the highest settings, that could take a long time. Now, if it's on the desktop, well, we don't care if it takes a day or two. But if it's on your laptop, that would chew up your hard drive time by a lot. And working on the desktop has all sorts of problems in terms of custom materials. So another thing that you can do is you can duplicate the view, like we've been doing with all our different views, and then just render halves of it. And that will often get you the 7,000 pixels that you want. Just send each half to the render cloud, and then make sure that you leave enough of an overlap that you can recombine them in Photoshop and end up with a humongous image. And that's probably the easiest option for most of you. The last one is the one I do not recommend because it messes up your image, and that's called upsampling in Photoshop, which is basically take an image that's too small and make it larger. This ruins some of the good work that you do creating custom materials and making interesting materials and lighting by softening everything. It basically makes Photoshop guess what the pixels would be that are missing when you double the size. But if you are absolutely stuck, resampling can also work. And if you do that, be sure to use bicubic. So and you just go to File, Image Size, and then change the image size. Anyway, when you are making such a large image, you want to make sure you refine the materials that are in your project. All materials in this humongous view are going to need to be really well done. And as just a review or a reminder, every material isn't just a color or a picture. It also has texture too. So using things like bump maps are going to really help. Just review the video that I posted on Canvas that talks about materials. So anyway, and especially materials that are up close in view, those are ones that you're going to want to modify. What about lighting? Well, lighting is obviously really important, and the number one mistake that I see is people using the color temperature that is very unpleasant and yellow to look at. All your light sources need to use this cooler color temperature. The fluorescent daylight preset on Revit's light fixture options is the one you'll want to use. That's the one that looks the nicest. You really can't adjust for that yellowness after the fact. The other thing that you can do is you can display lighting to see where it's going. And this is more of a design element. If I go into Revit and I look at the visibility and graphic overrides, if you go down to where lighting fixtures are, the light source is generally not displayed in, say, a perspective view. You can not only turn that on, but you can even control the color of the line weights that are described, that are used to describe the lines. So, for example, I'll use magenta here, and when I hit apply, now suddenly you can see the light sources. You can see where they're going, and for instance, if these were meant to focus on this painting, I can now see, oh, they're not working. They're not going in the right spot. And you can modify them either by rotating the light fixtures or changing the numeric value of the light fixtures. So in this particular light fixture, it's a fixture that can be aimed using an angle degree. It's a 60-degree tilt. So you'd have to actually modify the type of fixture. Anyway, you can also modify the photometrics of the light source to either use a standard light source that's a point source instead of more of a surface, or you can use an IES file. IES files are complex geometric descriptions of light distribution. You can also modify the lighting component geometry as needed. So obviously emitting light from a shape that is appropriate to what you're trying to do is the most important thing, and point, line, plane or circle, and then the distribution, how does it come out of that shape is obviously important, and this is what it looks like when you preview it in Revit. Often you have to move the light source location up or down in the light fixture in order to make it work. One last thing that I often see is that the cone for the recessed light doesn't work very well. It doesn't glow. The only sort of surefire way to make that work is to actually use a slightly glowing material for the material of the cone on the recessed can. Often the light comes out, but it just doesn't look like it. And finally, what I'd like to talk about is color managed workflow, and this must be done in the Digital Print Lab on a Mac, and save your large format rendering as a PDF file. And to do that, use Adobe PDF. That's the one that's going to get you the high quality print. Obviously change the page size to be whatever matches your file. And to soft proof it, you'll have to view it on Photoshop on the Mac, and we'll go over this in class with Michael Miller, but what it will allow you to do is view how your image will be color shifted when you go and print it on different printers. So for the week following the week we come back from vacation, we're all going to do a printed test strip to actually look at the colors and materials. Finally, the submission requirements for this project are on Canvas, but here they are. And for each, I'd like you to have a sentence describing what this particular view shows best or worst. So under each, just have a short description. And for homework for next class, I'd like you to have rendered all the views for this particular project so we can take a look at it and do some last minute troubleshooting.